session about the workload automation, creating new workloads and running your workloads or existing workloads or new workloads or any workloads in Lava. So the idea for this session came from the fact that we had a request like 3 months ago. We got the request from kernel working group about testing their changes to the I/O scheduler on Android. So they wanted to add BFQ and check it versus CFQ scheduler. So we needed to modify one of the workloads available there, and that was their use case. So we came up through the whole process, and so we want to present how it actually works. So not sure how that works. So we'll go through the process of creating new workload, like most likely not from the scratch, but from modifying the existing workload. As Lisa presented last Connect, the Workload Automation provides means to actually create a template for a new workload if you're interested to create one from scratch. So I'm going to briefly present the existing workloads, like the list of existing workloads for Linux and Android, then how to create new workload, and the last part of the presentation will be a demo of how our modified workload actually works, and then how to use workload automation in Lava, which is maybe a bit side topic to this, but I guess it also covers like parts of this session. So let's try. So firstly, I'll probably remind some of you who might not be familiar, like how workload automation is structured. So it has several pieces. It abstracts the layers of the tool, so it abstracts the targets, it abstracts the workloads, then saving the results also has an abstraction layer, so it's easy to add methods to save the workloads. And the last bit is resources. Resources is basically anything that workload automation uses, so it might be either the stuff that is downloaded from the network, or some variables, environment variables, or whatever. So for targets, so there are existing. Not here, because. All right. So there are existing targets that are already available in workload automation. The most used one is AOSP, which connects to the board, to the target boards with ADB. Then there is Linux target, which connects to the board using SSH. So the board needs to run SSH daemon. And then we had a use case for running workload automation directly on the board without using any connection. So Chase prototyped the local Linux local connection, which basically means that you go to the local shell instead of SSH or ADB shell. We have a prototype. It wasn't merged to the code, like to the upstream, right? Because
they are developing the next branch. The next branch will be based on the library, and they will have the local Linux support. Okay,
so we'll probably stick to our prototype, and it will be dropped at the point when workload automation upstream adapts the new library. So there are a couple of predefined targets. I don't remember them all. So the ones that we use in our lab are mainly Nexus 10 and Juno R0. So those are used for AOSP, and we use those in our lab. It's pretty easy to define a new target. So we just need to define the CPU architecture there, like write it down in the code, and the means for connecting, and probably some other bits that are board specific, but not well, that's not mandatory, so it will probably work. Then, as I said, there is a list of available workloads. It's pretty long. So for the Linux workloads, most of them are based on the on the open source tools like those cyclic tests or Hackbench or those other simple benchmarks. But there are also workloads for tools that are not open and they require some NDAs like Spec 2000. I've not been using those proprietary ones. Just use the ones that are open, and that's basically that's the easiest bit here. So Workload Automation, like the upstream, contains some pre-built binaries, but you probably don't want to use them. The easiest is to just provide your own binaries. Same with Android. So Android cases are included, like Linux workloads are included in the Android list as well. And apart from that, there are the APK benchmarks, the graphical benchmarks, and for those, Workload Automation provides automation, like automation scripts written, like composed with UA Automator. So you need to make sure that the APKs that you're using match the ones that Workload Automation wants to use. And the APKs themselves are not included because of the licensing issues. So you have to have the APKs from elsewhere. Then, as I said, results are abstracted. So results are saved to in the Python code in Workload Automation. And then they can be saved in various formats, so like comma-separated values, JSON, SQLite. Like yesterday when we were finishing this presentation with Chase, I learned that it can be even saved to IPython notebook or MongoDB. So never tried that, but it's there. Yep. And the resources. So wherever Workload Automation needs something, it will try. It will be defined as a resource. So it can be an environment variable. It can be a data stream. It can be a file or APK. So those are all resources, and they can be either stored locally. They can be stored hosted somewhere. So Workload Automation in the runtime will download your APK from some host. And use it for running the workload. And that's the chart from WA docs. So it basically shows how the workload runs. So how it runs on the target, on the host, and how the results are processed. So it can be. Like there is a bit broader description in the WA, but we don't want to go into the details at the moment, so it will be a bit lengthy. All right. Okay, so to the main subject. So our main goal was to create a new workload for kernel working group. They wanted to measure the latency that is caused by the background workload when launching the apps. So Workload Automation upstream at the time when we started already included the app start workload, which basically measures exactly what we needed. So it launches the application several times and measures the mean time of start, like mean time from starting till application is launched. The only bit missing was adding the background workload. So so that's basically what was added. So when designing a new workload, we need to decide whether we want the workload to work, like which target or which environment is it meant for. So in our case, it was an AOSP workload. It's not supposed even to be attempted to be run on Linux because it's a different beast. It's a different kind of workload. So apart from that, if you're designing your workload to be, for example, a shell script, it also need to be considered. So for AOSP, Workload Automation provides a pre-built BusyBox that runs on the target. So in case there is no BusyBox there, it is just provided and can be used. And that's exactly the case we had. So we were not able to rely on the shell that is on the board. So we're using this pre-built BusyBox. Then again, connection is important, as I listed in the beginning. So AOSP targets, AOSP workloads use ADB. ADB can connect to the board either using the IP or USB link. That makes no difference from the workload automation perspective, but it makes a huge difference when it comes to automating things. So USB is much harder to work with. Then again, if someone wants to work with the targets, it's worth to consider whether we are using the tools that are available on the target or the tools that are just host only. So, like an example might be automating on AOSP using UI Automator. And then UI Automator provides you with two interfaces. One is the Java one, and the other one is XML based. So you can ask UI Automator for a dump of your screen, and then work on that using just tools based on the host and provided by AOSP. And then the last bit is like what the actual workload will do. In our case, the main measurement is the time of launching the application, and the background needs to be loaded with some I/O traffic. So that was the workload. Now, as I said, Workload Automation provides with, as Lisa described 6 months ago, thank you, Lisa, provides you with a tool that basically creates a skeleton for a new workload. So if you type WA create workload, it will create all the necessary files with like empty content. So the content to fill in. So the first bit to fill in is the init.py file, which derives it creates the class derived from the base class workload, and it's your class. So there are bits to fill in there. So the first thing is to define how to set up the workload. In our case, we needed to prepare a shell script, and the shell scripts can be created on the fly from the pre-existing templates. Then the shell script needs to be filled in with some values that you pass from the command line. Those values are the workload parameters, and the parameters are defined. Again, this is a resource that Workload Automation defines, and those are also defined in the init file. So you can add as many parameters as you want. Then the name of the parameter can be reused in the shell script template as a variable. So anywhere the shell script needs a variable that should be passed from the command line, it can be used as the parameter can be used. Also, parameters can be passed from the agenda files. So say mechanism applies here, so if the workload defines a script or defines a runtime parameter for app or whatever, then passing the same from either command line or agenda file works. And the last bit is the workload teardown. So we want to leave the device, at least in ideal case, in the same state that we started the test with. So we want to first copy the results that we are interested in, and then remove all the temporary files, uninstall our APKs, and do this kind of stuff. So part of this is already done. So for example, uninstalling of the APKs is already done by Workload Automation. So it's just custom things that need to be removed by hand in the teardown that we overwrite in the init. So about the templates. So templates are based on Jinja 2 engine. So for those familiar with Django, for example, it's very similar to the Django templates. And they are rendered in the same way. So there is the template is taken as a whole, and then the variables are replaced from the context. The context comes from our parameters that we pass to the template. If the case is easy enough, so for example, we have just a command line call for cyclic test, Hackbench, or whatever with a couple of parameters, those can be filled in just in the init. So we don't need a template for calling in a shell script. But in our case, it was much more complex, so we needed a template. And then, as I said, all the variables that are defined in our workload can be passed either to the template or to the command line call. Yep. Another beast is creating the UI-based workload. So Workload Automation relies here on UI Automator Java API. So whenever you need to do some clicks on the UI, you need to know exactly what you're using. So the APK, the underlying APK cannot change, because otherwise the UI automation will basically break. So if there are like new dialogues coming up, or the location of the buttons changes, then it will not work. There are UI Automator scripts sources in the Workload Automation code base. And there are pre-built Java classes for that, but again, they require the precise versions of the APKs. So if you're, for example, not able to get the old enough APKs to work with Workload Automation, you have to update the sources. And it also supports the background tasks, so it can like do what we were doing. So launch the APK, control the APK from UI Automator in one thread, and then another thread run a shell script, for example. Okay, so we'll probably want to switch to the demo, so about what we were talking about. Is it still running? Okay. So can we switch to the other source? So we have our Android device, which is Hikey, and well, it would be nice to see that. I'm just running the workload with the background load. So what it will do, it will launch the calculator, right? It will launch the calculator a couple of times with the background load, and then what we're recording is the mean time to launch the application. So this was the use case the kernel guys were interested to. So in the beginning, the script basically launches it 3 times to like warm up, fill in the caches, and then the next 10 launches are 10, I think. Oh, okay, there are just 3 because we wanted it to speed up for the demo. So the next 3 are just for are meant to measure the actual thing. In the real use case, we're using 10 or even 13 iterations of each up, and then 10 iterations of like the whole cycle. So this is this will take some time, and then those numbers that we generate from it are saved in the results file. So then we can compare using different. So in the agenda files, we provide the parameter which says, okay, use BFQ scheduler or use CFQ scheduler, and then we can compare the numbers that we get out of it. Iteration, just third iteration. Let's see if that's. Oh, it will run 10 of them. Okay. last one. Should finish in a moment. No, it will run. Okay, because, yeah, all right. So it's running both BFQ and CFQ at the same agenda file. So first it's running with one scheduler, then it's running with the other scheduler, and this makes one iteration. Goes a bit. Between iterations, yes. Between launches, no, if I remember correctly. So that's the case of our script. The question was whether the caches are cleared here. So yeah, I was also asked to compare with clear and dirty caches, and both cases just required a slightly different script to be run, and that can be done using the template. Right. So still running. Any questions so far? Okay. Let's wait. I hope this is the last one.
Hello everyone, I'm come from Reboot, and my company want to send one product to Linaro and test by Nava. What should we do? We want to know.
Sorry, so what's the question?
We want to send one product to Linaro for Lava testing. What should we do?
Okay, so send it.
Send.
Yeah.
Okay.
So we need at least 5 pieces, right? At least 5 pieces.
Okay.
That's so for us to work to be able to work with that in the production and in staging environments, then you probably need to specify what exactly you want to test, and then we can take it from there.
How about the source code? How to manage the source code?
Source code for tests?
The whole source code, the whole platform.
Well, okay, so send it. No joking. So basically, that's a different thing. So you're asking about the end-to-end setup. So in order to test stuff in our lab, we need a build. So you need to talk to the build guys, to the build team, to provide you with the build, and then that's the build we're going to test on the boards.
If we send the whole source code to Linaro, could you build the whole room and test for us?
Yes. Yeah. So then the additional questions from my side come. Okay, we test for you. We find a bug, and what happens next? Are you going to fix it?
I think my company will cooperate to. I think my company and Linaro can cooperate and fix the bugs together. If the bugs were caused by my company will fix the bugs.
Okay. So let's. I guess this is some kind of a bit broader discussion. So we can take it offline after the meeting. We can discuss.
Okay. Thank you.
All right. So there are more iterations than I thought. Yeah, I think it's 10. All right. I'll just stop it and switch to the other one. Okay. Another question, Serban?
I was just wondering if you happen to know if Google uses like a similar system to what you guys are using for testing applications?
I have no idea.
Okay.
So what was the answer? If you could use the mic, because...
There is some usage of WA.
all right.
There's pockets of usage of WA.
All right. So do you have any details on that, or no? All right. Okay. Is
And
there?
then
We,
we can shoot it without.
okay. We can show it at the end. Yeah, we're here. Previous slide. Previous slide. Previous. No, two back. Back. Yeah, oh, one forward. One forward. Yep, here, okay. So, about WA in Lava, so I guess that's more or less the question. So WA is sort of self-contained testing environment, so it can, the only thing that it doesn't do, as far as I can tell, it doesn't flash the board with the software, but apart from that it can control the power cycle, so reboot the boards and control all the parameters and execute the tests and so on. And this is the part of the work that Lava is actually doing, so they don't like each other very much. But it can be done. So basically what we need to make sure is that Workload Automation doesn't reboot the board, and that can be done. So we need to make sure that all our agenda files contains the reboot policy never. And the other part of it is that Workload Automation, as I was talking in the beginning, is like a host target-based environment. So the Workload Automation itself runs on the host, and it connects to the target using ADB or SSH. And that's also something that is not it's not trivial to do in Lava. So basically what we had to do is to create the hosts, which are KVM-based virtual machines, and those run Workload Automation host code, and then connect them to the target machines. When this first started, we only had Juno boards, and Juno boards running AOSP work with IP-based ADB connection. So we're able to connect from any KVM to any Juno, basically based on AP traffic, which was pretty convenient. But then we got a request to support USB-based devices, basically. Basically, it was Nexus 10 devices at first, and then I think Nexus 9, high keys, and all other, all other based USB based. So this created a problem that the USB connection is basically limited with the hardware wire that needs to be connected between the host and the target. So that created additional level of complexity in the lab, but the principle is the same. So we have the host running somewhere, and we have the target running on the board, and those need to be controlled. So both ends need to be controlled from Lava, and this creates us something called Multinode Job. So one node is a host, one node is a target. Both of those nodes need to talk to each other and run the agenda files, basically. Right? Yes. Yeah, thanks. So this is our current setup. So the big box, the big white box, is the JSON job definition. So we define two nodes here. On the left-hand side is the host job, and on the right-hand side there is a target job, and they need to talk to each other in order to pass the synchronization point. So the job goes like this. So first the host starts and waits until it gets the either IP address or ADB ID from the target. The target boots, reads its own IP address or its own ADB ID, and sends it to the host. Then hosts, and then starts the wait until the tests are complete. And then the host does all the steps required on the host, so basically installs the WA. At the moment we always install from tip, but I'm planning to change that to install from released versions, not from tip. Then creates all the agenda, all the config files. So config file contains the IP address or ADB ID of the target, and then in our multi-node job definition, we define also which agenda file to run. So there are a couple of agenda files that we deliver. They are coming from our work that we did for ARM Power Management Group. So these are HMP and AES benchmarking, and from ART Group, so benchmarking for ART stable branch. And then the workload is run, results are collected. There was another trick to make sure that when we run several iterations, that we collect results to the same place. And then once all the iterations were run and all the tests were completed, host sends the signal back to the target saying, "Okay, I'm done." And then both ends finish their test jobs, and the whole test job is completed. Right. Yeah. So as I said, there are a couple of agenda files that we already provide. So they are mainly for Juno, for HMP, EAS, IKS benchmarking, and for Nexus 5, Nexus 9, and Juno for ART benchmarking. I guess they can be considered as an examples. These are the ones that we use, and everyone else's use cases might be different. So they have some examples of how to use the parameters, how to set the parameters on the board. So Workload Automation, for example, allows to control the CPU layout, so we can turn on and off some CPUs, or change the I/O scheduler, or do this kind of thing. Right. And as I said, there was a problem with connecting USB-based devices to Lava, because there is a need for physical connection. Now, just recently, a couple of months ago, we got the hardware from the company called Cambrionics. They have a product called EtherSync. I think it's still not a product, it's still a prototype. And the EtherSync basically has the USB uplink based on IP traffic. So now we can hook up our USB devices like Nexus 5, Nexus 9s to the hub, and then the uplink from the hub goes to Lava with IP address. So and then like the last bit to hook up the USB device to our KVM is software utility. So basically there is a driver that Cambrionics provides that allows to connect the hub to the virtual machine, and then it creates like a virtual USB device, and ADB is able to connect to this device. I checked this just before Connect on Friday. It works just fine. And hopefully we'll get that in Lava, in our lab in Cambridge, supported in the next couple of weeks. So that will give us an easy support for Nexus 5X or 6P for high key with AOSP build, and we can run workload automation on that. Okay, that brings us to the end. So any other questions?
I'll just speak really loudly.
No, that doesn't work because we're recording. Yeah.
Dumb question.
Yeah.
So do you post your results periodically somewhere that people could see? Kind of interested particularly on that.
You mean the benchmarking results?
Yeah.
No.
Even for like dev platforms or open stuff?
No. Still no.
Okay.
Well, they are pretty easy to reproduce though. So
Sure.
we post the builds, we post our setup that we benchmark with, so you can just do it yourself.
Well, so WA comes from my group, so we do that. But,
Yeah,
and we equally do not publish, but I was just curious whether there's going to be some...
The problem is with the policy that we have, that we are not allowed to publish
Fair enough, yeah.
the benchmarks without the vendor consent. And we don't have any real need for that.
So you only asked us to stop.
No, I'm just curious.
Okay. Okay. That's okay. Let's try to finish the demo.
So I was saying, like, we have been generating test reports for releases, and we will be sharing to the particular vendors those benchmarks. So not in Lava, basically.
Yeah, no, that's fine. That's
Okay. So.
I have set up an environment of Lava locally, and I found one question. I have one question to ask. If we must reboot every time to test the one case, could you test continuously without reboot?
Well, it depends on your use case. If you need to reboot, then your test job definition needs to contain the reboot parts.
So we must reboot if we test the cases, the different cases.
Well, it depends on your use case. So you can do either, but you need to decide, like it's a test design phase. So you need to decide whether you need to reboot or not. So what is your use case? Lava can do both. So it can reboot or it can run without the reboot.
Oh, well, how can we, what will we set if we don't want to reboot?
So, okay. So you cannot let Workload Automation to reboot the board, but Lava can do that. So Lava will reboot the board, and Workload Automation will only run workload.
How to set parameter?
Yeah, we have examples of the jobs that you can just copy and use. Okay. I wouldn't advise for doing so anyway, but so there are, like, if you do that, there are like there is another range of problems that appear. So as I said, these are multi-node jobs. So you have the host and you have the target. If you reboot, you have to basically reboot both of the nodes, or sort of reboot both of the nodes. And then if they don't come in sync, like come up in sync, then you basically run different tests that you would like. And finally you end up one node waiting for the other one and both timing out. So that's what happens pretty frequently for us if there are some problems.
Thank you.
But it can be done. It can be done, and we are actually doing that. But yeah, you have to expect that it's not working perfectly. Okay. Yeah. Just press the input.
Maybe too late.
Input. Yeah. Then enter. Okay. Right. Question.
I've got a quick technical question.
Yes.
For Lava, you have in the multi-node configuration, you basically run on target and on host. And the first thing you do on target, you basically post back the IP address to the host.
Yeah.
How do you detect the host?
What do you mean detect?
So
How are you sending an IP from target
to the host?
yeah, just
So
by host name? By
No,
design, the
Lava
host name?
provides an API for the nodes in Multinode Job to talk to each other. And,
Okay.
and this is done by the means of Lava API.
Okay, which is probably in the form of some scripts.
Yeah, it's a script. It's a script. So Neil probably can brief you on that. Like the downside of it is that the target has to run some shell, which needs to be POSIX compliant shell.
Mm-hmm.
Yeah.
Okay, thanks.
Yeah, but that's no, that's the same. So you need to pass the USB ID. Yeah. So, but that's exactly the same. Yeah, the font is small. Okay, try. Oh, it's there. Okay. Yeah. So so these are the results. For the moment, we just used comma-separated values and have the execution time of BFQ and CFQ based workload. So in here there is a name of the workload. So these ones are BFQ workloads. These ones are CFQ workloads on top. And yeah, you can. So I think we run with dirty caches now. So with dirty caches, that difference is small, or there is almost no difference. Yeah, it's a. Well, actually, CFQ is faster, if you can see. Okay, you're right. Yeah, you're right. Sorry. I took the total execution time, which is right. Yeah. So no, it's probably with clear caches, not with dirty caches. Anyway, so this is how we had this workload running. Well, we have DBs. I guess it's not used for this use case at the moment, so we have just results in the CSV file. But as I said, they can be even posted as IPython notebooks, which is pretty cool, I guess. Okay, so that's all I had for today. If there are any other questions, so we can close. Thank you very much.